Hello students, welcome to the session. Before starting the actual topic, let me tell you a few things about this chapter. This chapter is very important in terms of so many competitive exams and so many fields you might choose after doing your degrees. This particular subject defines how the processors, controllers and ICs do work. So, if you are going for some IIT or any GATE or any other competitive examination, this subject and this topic is very important. If you understand this particular session, then remaining sessions will be very easy. So, your today's assignment is to take a notebook, take a pen along with you, and while watching the video, you just note down your notes about this topic, draw the diagrams and upload them. And same thing you can use for the revisions. So, let us start with the topic. Hello students, let us now discuss about the semiconductors. This chapter is very important in terms of understanding this subject. The entire electronics nowadays depends upon the semiconductors. So, let us begin with the semiconductors. Let us have a recap of the things we have discussed in earlier classes. We have discussed that we require power for doing all kind of work using our gadgets. The basic element in our gadgets is battery. Without batteries, we cannot run our system. At home, we require power supply sent by the electricity board. Without them, we cannot use our systems. So, the most important thing is that we should have a driving force which is given by the electricity or battery. Everything around us, the universe and the planets, they are all made up of atoms, and electrons rotate around the nucleus of the atom. It resembles to the solar system of our planet. Here we can see the sun is at the center like nucleus, and all the planets rotate around that particular nucleus. Similarly, electrons are part of atom, and atoms are part of every living being and every material present in this universe. So, at the nucleus we get the charges. There we have protons and neutrons. They form a nucleus, and around that electrons rotate. And these electrons are very small, and these electrons are very important object in any electronic gadget or electronic circuit. So, if we discuss the definition of electronics, what is definition of electronics? It is the design of circuits using transistors and microchips. What are these microchips we use in our day-to-day life? Mobile phones, the laptops, the computers, the televisions, everything they have the microchips, and these microchips are made up of transistors, and transistors are made up of semiconductors. So, the most important part in the present day electronics is semiconductors, because we made transistor using semiconductors. Along with this, the study of electrons in semiconductors, conductors, vacuum or gas is also electronics. We have to discuss all those things. So, what is there in the universe of electronics? We have conductors, insulators and semiconductors. Everything rotates around these three parameters, and conductors lies on the top in terms of conducting electrons. Electrons are always available for the conduction in conductors. In insulator, we don't get electrons for the conduction, but insulators play a very important role in the electronics. And at the intermediate level, we have semiconductors. Let us explore how we are going to deal with them. So, before that, let us discuss about the conductors and the usage of conductors. Where do we use conductors? We use conductors in our day-to-day life. The wiring inside our house or in offices or any other places are made up of conductors. In conductors, there is a metal sheet covered by some plastic material. So, this plastic material is insulator and the conducting metal inside is a conductor. Plastic coating we use for the protection. These kind of various cables we use for connecting to the cable dish in our day-to-day life. These are also examples of conductors as well as insulators. Then where we use insulators? Insulators many times we use, but we don't notice them. Usually we use them on the power lines. You might have seen power lines like this. There the part available on the line is an insulator. Whenever appropriate topic comes, we are going to discuss about them. Along with this, insulators are most widely used in the capacitors. Let us have some interaction about capacitors. Let's have a brief interaction. These are various kind of capacitors. If you might have opened any gadget like mobile phone or old television, you can see there are various components mounted on the board, on say motherboard. So, these are capacitors, but capacitors, if you know, they are kind of insulators. In any assembly of capacitor, we get two plates of conductor separated by an insulator. That means there is no electrical connection between these two plates. There may be various shapes of capacitors. There may be separation of insulator between different shapes. Now, if we remember the definition of any electronic circuit, the definition is that we have to close the circuit. The circuit must be closed from positive end to negative end. But imagine if you have a capacitor between them, then there is an insulator. So, there is no connection between these two plates. So, can we call it a closed circuit? Yes, still we can call it as a closed circuit because it uses the transfer of flux inside the plates. That is very important concept we are going to study in next sessions. So, this is about the insulators. Then let us discuss the difference between conductors and insulators. Conductors we have copper, aluminum, steel, gold, silver and so many other metals. Insulators we can use plastic, rubber, glass, wood, cloth. But what is our concern in this chapter is about semiconductors. The semi, the meaning semi comes from half. So, they are half conductors, semiconductors. So, if they are half conductors, they are half insulators. So, they are half conductors and half insulator, and this property makes them very important in the study of electronics. So, mainly semiconductors are classified into two groups. One is elemental, another one is compound. Elemental are two basic components, silicon and germanium. In compound, we can make them in the combination of two different materials, like we have gallium arsenide here. These types are not included in this particular topic what we are going to study. Here mainly we are concerned about silicon and germanium. So, we will discuss everything about silicon and germanium only. The very first thing you have to remember throughout this subject is that silicon having 14 as atomic number and germanium is having 32 as its atomic number. This is very important. So, both of them have 4 valence electrons in their outermost shell. So, what is the history of these semiconductors? So, and how we got requirement of these semiconductors. So, to understand that we have to look into the history. So, let us discuss how was the life before semiconductors. Before the usage of semiconductors, the systems were made up by using the vacuum tubes. There were large vacuum tubes and they used to do the functions of transistors. These were heavy and bulky. These tubes were used for earlier televisions also. If you might have seen in any old movie, there were black and white televisions with a large vacuum tube. Even until 4 to 5 years back, there were lengthy and bulky televisions as well as laptop systems. So, what was there in that? It was a large vacuum tube, and where there was movement of electrons inside this particular tube. There were two plates, one was cathode, one was anode. They used to rotate from one end to another end, and these were used extensively for the production of visuals on the screen of the system. So, this was the life before the usage of semiconductors. It was bulky and it was lengthy, it was mostly black and white. So, now let us this one is the first computer. The first computer was having the size of the entire big room, and now you know what you have in your mobile phone is more sophisticated than these earlier gadgets. So, let us move towards. So, this was the life before inventions in the semiconductors. Now, why we study semiconductors? Because it got lot of advantages. Right from the mobile phone we use, the processors we use, the memory cards and the motherboards and various gadgets, televisions and so on. Everything which we use nowadays and belongs to electronics comes from the semiconductors. So, how exactly it happens? How we are able to do so many good stuff out of this silicon? So, we have to discuss that process here. We get silicon from nature in terms of some sand or stones. Then we take it to the manufacturing unit. We melt it and we give it a shape. Let us discuss the steps one by one in the following sections. Then these semiconductors are taken to the labs where manufacturing takes place. There are various steps involved by using this silicon. First, we get this silicon in raw form. There are sands or the stones. Then we have to clean it. Once they are cleaned, then it is melted. They are melted to make a proper shape of that silicon. But cleanliness is very important in this process. There is around 99.99% cleanliness maintained in these manufacturing units. The reason behind it is that even if there is a small particle present in the process, it may damage many ICs. We know that in company there is a mass production. In one batch there will be production of thousands and thousands of ICs all together, and all of them are made up of silicon or germanium. Then after going through various processes, we get a furnace where this silicon is melted. They are melted and given a particular shape. The shape is called as ingot. These ingots of silicon are made in under very high pressure and temperature, and suddenly they are cooled down to get the shape of the cylinder. After that, these ingots are made into small wafers. You can see a plate here. There are various plates made up of this particular ingot, and they are called as silicon wafers. And on this wafer we make various chips, and we get lot of chips on this particular circular disc, and the corner chips get out of the production. We get the chips which are present in the rows and the columns. And what is there in a particular chip? In each chip there are millions of transistors mounted. So, we get these chips, and these chips have various transistors placed on themselves. They are created on the same material. That is why it is called as monolithic technology. Mono means single, lithos means stone. They are made on a single stone of silicon. On a single stone, various parts, various sections of say CPU are made, and all of them are made by using the sand of silicon. So, like this we get the journey from sand to chip, and all those things are made by using a proper programming. The programming is done by engineers, and they make the patterns of mask. Suppose I want 1000 transistors at this particular position, then I will create a mask which will give the entry of bombardment of the light, which can create that particular section for the ready for the doping. What is doping, that we will discuss in appropriate stage, but all those things are required for the production of ICs. So, after doing all those things, we get the system which we use. So, why semiconductors are so great? Previously, why the things were so analog and so heavy and bulky, and now why things are becoming so flat and so user friendly? For that, let us have the discussion about the semiconductors. As we know that semiconductors, they work half as conductor and half as insulator, but this functioning is done in a proper controlled manner. We can control them. Whenever we want them to work as a conductor, they can work as a conductor, and whenever we say don't work as a conductor, they stop working as conductor. So, in digital system, the entire thing, the complete communication is done in terms of zeros and ones. We don't have any lengthy analog signal in digital system. So, if I want to say my logic is 1, then I say it's yes or it's on. If anything is on, that means it's conducting. So, whenever I say my semiconductor is on or conducting, that means the logic is 1. And whenever I remove the supply given to my semiconductor, then it will logic 0. That means no. That means there is no conduction. So, everything between on and off is considered as the digital logics of ones and zeros. That makes the digital system. And though no conduction means it is an insulator. So, we use semiconductors because they have both the properties of semiconductor and insulator. So, let us discuss why digital systems are so important here. Why should we go digital? If you remember the earlier tape recorders and the cassettes in that. So, what was there? There was a magnetic tape, analog tape, which used to consist of having different songs on that. We used to record songs in that, and there were around 30 to 40 minutes songs recorded in one cassette record, and this used to be played by a recorder. But nowadays we have memory cards. The memory cards are so sophisticated and contain thousands of songs in a very small space. Another example is the old days televisions. It was a heavy bulky television screen placed in a vacuum, and we used to get signal through particular wire, through antenna, and there was a cathode used to get heated and the electrons used to get released, and these electrons were bombarded on the back screen of the television, and we used to get the output on the screen. This was an old system where heat was required to create the beam of electron. When we used to give heat, the cathode used to get hot and it released the electrons, and it was heavy and bulky. But nowadays if you see the flat televisions, flat screen computers, there is no need of any heater or there is no bulky or heavy system. So, that is something which is very important. So, digital circuits are easy to design, they are cheaper than analog circuits, the hardware implementation is easy and it is more flexible. So, we can surely prefer about the digital signals. So now let us have classification of metals, conductors and semiconductors. The first parameter which we can consider is on the basis of conductivity, how good they are in conduction. The conduction means the flow of electrons. If a material can carry more number of electrons easily, that defines its conductivity. If any material cannot flow the electrons in proper way, that means the conductivity of that particular material is less. Conductivity is denoted by sigma, and the opposition to this conductivity is called as resistivity. It is related to resistance. It is given by rho. The rho is equal to 1 upon conductivity. So let us see the values of conductivity for metals, semiconductors and insulators. For metals, if you see, the resistivity is very less. It is in negative. So we can say it is 10 to the power minus 2 to 10 to the power minus 8 ohm meter. At the same time, conductivity for metals is in positive. It is 10 square to 10 to the power 8. For semiconductor, it lies between positive value to negative value, because whenever we want, we can use it as conductor. When we are using it as conductor, we get conduction value in positive. Whenever we use it as insulator, the value of resistivity is in positive and conductivity is in negative. And for insulators, we have very high values for resistivity and conductivity is very less. This value of conductivity for insulator is in negative because they do not conduct. So let us discuss another parameter on which basis we can classify these materials. Another basis depends upon the energy bands. What are these energy bands? So let us now focus on the structure of atom. We will choose atom of silicon because silicon is most widely used semiconductor in the production. So that let us consider about silicon. The atomic number of silicon is 14. So these 14 electrons we have to divide among various shells. The core of any atom is nucleus. Nucleus is positive in nature, and around nucleus we get various bands or orbits in which the electrons rotate. So in first orbit we have 2 electrons, where 2 electrons rotate around the nucleus. Then in second orbit we get 8 electrons, they rotate around the nucleus. And what are the remaining? There are 4 electrons. So 2 we consumed in band 1, 8 we consumed in band 2 or shell 2. So total 10. Remaining 4 they remain in the outermost shell. So outermost shell is also called as valence shell or valence band. In silicon as well as germanium, the outermost electron number is 4. So that is something very important in terms of silicon. And what all electrons do? They rotate around the nucleus. So which electrons we get for the conduction? How the conduction happens? Let us discuss about that. What case we have discussed about one orbit or one shell is for one atom. We have so many atoms connected together in an material. Suppose there is bonding of atoms in material throughout its density. So we will convert them into consolidated bands of energy. So say I have so many numbers of atoms. So I will represent the entire band, the entire nucleus in one range. So if I have 3 bands, band 1, band 2 and band 3. So all consolidated electrons in that particular band we can represent by a complete patch of region. So we may have band 1, band 2 and the outermost valence band. So if we consider the representative nucleuses of all the atoms present in the material, because we don't have only one atom in a material, then there will be a very close region to nucleus, the first band or shell 1, that is very close to nucleus. After that, we will have shell 2, that will be band 2, the intermediate level for silicon, and there is third band. What are there in all those bands? There are electrons in all those bands. Now, the electrons present in the first band, they are very closely attached with the nucleus. That means the force of attraction between this nucleus and the first orbit electrons is very strong. What is current? Current is something when electrons flow. For making them flow, I have to bring out electrons from the atom. So, if I try to bring out the atoms of first shell, it will be very difficult because they are very strongly attached with the nucleus. So, if I apply what we do to make electrons flow, we apply some electric field in terms of voltage. So, if I apply electric voltage to the band 1 electrons, they will not come out of the shell, they will not come out of the structure of atom, because there will be strong attractive force from the nucleus. So, first band we are not going to get for the conduction. Let us discuss about the second band. Second band is in the intermediate stage, but they are also strongly attached with the nucleus. So, if we apply force on the second orbit, those electrons also not going to come out of the shell, because they are again closely attached, strongly attached with the nucleus. Then the remaining is the outermost shell. Outermost shell electrons are weakly attached with the nucleus. That is the place where we can have some hope to get electrons out of this particular system and become free. When they become free to move, then only we can get the conduction. So, if this electron is applied by electric field, then nucleus force will not be able to stop it. So, this electron will be released by this particular valence band. So, if we get any conduction, it gets because of the electrons present in the outermost band, that is called as valence band. From there, they jump for the conduction and they conduct inside the material or conductor. This particular imaginary place where the electrons move is considered as the conduction band. So, we are concerned about two main bands. One is valence band, that is the outermost band, and the conduction band. So, now let us classify materials based on these bands. So, we have insulators. Insulators do not conduct. Why they do not conduct? Let us discuss the reason. So, we have electrons in valence band, either it is insulator, semiconductor or conductor, all of them have electrons, because everything is made up of atoms. But which material can contribute their electrons for the conduction depends upon their strong attachment with the nucleus. If it is an insulator, the outermost band electrons are very strongly attached with the nucleus. They have very strong force of nucleus. Even if we apply external electric field, we are not going to get the conduction of these electrons. So, these bands are given in two places. Say we have one valence band and we have one conduction band. Energy levels of these bands should go from the bottom to top, from the valence band to conduction band. The energy level of valence band is given by EV, that is the valence band energy level. Along with that, we have conduction band, that is given with EC, that is energy level of the conduction band. Now, I have full of electrons in the valence band of insulator. If I apply some kind of force on these particular electrons, then also I am not going to get any electron for the movement. So, what I say there is a virtual gap, large gap between the valence band and conduction band. So, this gap is not any actual gap, this is virtual gap we use to represent the energy band diagram. This diagram is called as energy band diagram. We are representing energies of all different atoms in one particular band. So, if I have insulator and electrons are not able to jump for the conduction. So, I say that there is very large gap for conduction. So, this particular gap is given in electron volts. The unit of energy in electronics is electron volts. Like normal energy we calculate in joules, in electrons the small amount of energies are calculated by electron volts. It is given by small e, capital V, small e for electron and capital V for volt. So, it is electron volt. So, this gap is usually greater than 3 electron volt. That means, we have to apply more energy than 3 electron volt to get these electrons for conduction, which is not possible, which is very difficult task. So, if I require very large amount of energy which I am not able to provide, then I am not going to use it. It is termed as insulators. Insulators do not conduct. So, this is about insulators. Even if we apply larger force, we are not going to get electrons out of that particular material. So, we do not get any conduction. If we apply very high voltage, then also there may be small position change of electrons in valence band, but in any case we are not going to get them out of the material. This small change in the position in insulators due to very high level of electric field is considered as polarization. Then, if you talk about semiconductors, what makes semiconductors smart is that their ability to work as conductor and insulator as per our requirement. So, I have two bands, one is valence band and another one is conduction band. So, at normal temperature, we have electrons in the valence band. If I want to make them conduct, I have to send these electrons to the conduction band. So, energy level of conduction band is given by ECE and the energy level is going up. So, conduction band, we have valence band, and then let us apply some kind of force to these electrons present in the valence band. There may be n number of electrons present in valence band. Then what I have to do? I have to send them for the conduction band. That means it is a material where they will flow. There is no separate band kind of thing. It is a virtual concept. So, I will apply some kind of force on these electrons, and if they are able to jump to the conduction band. So, what I say, there is energy gap between valence band and conduction band, but this particular gap is very small. I say it is less than 3 electron volt. That means, if I apply small amount of voltage, then I will get these electrons for conduction in the conduction band. So, whenever I want them to use as conductor, I will apply small amount of energy and I will make them in conduction band. I will get the flow. And what if I do not want to use them as conductor? So, now my logic is 1. I want to make my logic as 0. I want to shut this particular system. So, what I will do? I will remove the supply voltage. As soon as I remove the supply voltage, all the electrons from conduction band will go back to the valence band. Again the same position. That means, now there are no electrons in the conduction and all the electrons are present in the valence band. So, this is what makes semiconductors work as digital system. I can control it. Whenever I say go up and conduct, it will conduct. Whenever I say go down and do not conduct, it will not conduct. So, we have this classification in terms of energy band. If we talk about conductors, in conductors there is no such energy gap. That means, we do not require any additional kind of energy to make electrons flow in the conductor. They are always available to flow, or they are always moving around the atom for the conduction. They are always ready for the conduction. So, there is no energy gap for the conductors. So, what we have to summarize? We have insulators, they do not conduct, and if we represent them in the conduction band, we say that there is very high energy gap between the conduction band and valence band. If we talk about semiconductors, we have an average gap. If we apply a little energy, we will get electrons for conduction. If we remove that energy, we will not get electrons for conduction. So, have a good day and let us continue our next session in next class.